All right, thank you so much. Okay, well, welcome. Thank you so much for coming to my session. I know that this is the session right after lunch, so some of you are digesting the food coma. And also, I have about 50 slides and about 55 minutes to get through them, so this is going to be fun and fast, and I ask that you save questions until the very end. I am super happy to talk with all of you after this is done, but I do want to get through all the content. So, quick introduction. My name is Katy Shimizu. I am a software engineer level 2, so mid-level on the Azure Functions team at Microsoft. I am actually a native to Minnesota. I grew up here, mostly around the Edina and South Minneapolis areas. And then about 2 years ago, I got a surprise job opportunity and moved out to Seattle to work on a product that I had been using as a customer for some time prior to that. And now I'm on the Azure Functions team. So, how many of you are familiar with serverless? Okay, this is good. You are in the right talk. How many of you have used serverless as a toy or just kind of tried it out? Also good, like the show of hands. How many of you have used it in production? Okay, that's more than I was expecting. That's good. That's good. That's very good. All right. So I can kind of zip through these first couple of slides, but I will go over them quickly just for folks in the audience who didn't raise their hands. The whole idea of serverless is not that there are no servers anywhere, but that you, the customer, think about servers less. See, this is how we salvage a term that some people really, really don't like. It's up to the cloud provider to manage your servers, to manage your OS and your firmware upgrades, to manage your uptime, to manage your scaling. And the serverless programming model is event-driven. So based on some event, you have some sort of little piece of code that runs very quickly, does something, and either has some side effects or dumps transformed data out to some other data sink. And the real value prop of serverless here is, one, that you as a business do not need to spend time maintaining servers, maintaining all of this infrastructure. You can get up and running and coding your business logic and paying attention to the stuff that matters very quickly. How many of you were in Lynn Langett's talk yesterday? Oh, okay, not that many. Well, Lynn brought up the example of A Cloud Guru, which does a lot of training and cloud training resources online. And they were actually coded over a month using about, I think, it took about $500 and one engineer from Microsoft who was home helping his brother. So this is kind of an example of how quickly things can get up and running when you are using serverless. And we kind of go into this in this slide. So you can focus on your business problems, you've got shorter time to market, and you can be very flexible because you're only billed for what you use. So there's the possibility of reduced cost of compute instead of provisioning one server and then keeping it up regardless of what kind of traffic is hitting it. This all sounds pretty good, right? Okay, so one of the main serverless offerings on the Azure platform is Azure Functions. This is what we think of as like little glue functions. And it is basically what you would expect. It is an event-driven model. You have some code that runs off of some trigger binding, maybe pulls in some stuff through an input binding from, say, a blob or a storage queue. And then it outputs whatever it's transformed it into somewhere else. This is kind of what it looks like. You've got a trigger that you set up. This is C# in Visual Studio. So we've got these attribute decorators that can define your triggers and your bindings right there in your code. And there's an output binding. So here we are taking information from one queue when it comes in and writing that information, doing something to it, obviously first, and then writing that information out to another queue. And the function.json is what we create. When we compile this down, this is kind of the definition of the bindings that our runtime uses. So that's a little bit of code, and you're going, okay, this sounds great, but I notice you're leaving a number of things out. Like, let's say I need to run in a VNet. Let's say I need automated testing or to run on premises, custom hardware, custom dependencies, real-time monitoring, automated development, sub-second latency, network isolation, state management. There's a lot of things here that You as an enterprise customer looking at an enterprise solution, either for developing a new one or transitioning an existing solution to a serverless model to take advantage of its benefits, are wondering, well, you haven't talked about that. But the fact is that serverless is maturing as a discipline and a model, and all of the cloud providers, I'm going to focus on Microsoft because that is what I know, have come up with various solutions for these questions and these problems. And I am going to do basically a breadth-first kind of search over pretty much what Azure has to offer. A lot of these are going to be very new. They were actually announced just a day or two ago at Build, if any of you caught the keynotes or the sessions there. Each one of these could be a talk in and of themselves, and indeed, actually, they are. And if you go on the Build website, you can see a number of the recorded sessions and streams. So let's get started. All right, let's talk about hosting options. So one of the things about functions that differentiates it from, say, Google Cloud Functions or AWS Lambda is that it is fully open source. We actually open sourced our scale controller as well. That's the internal logic on the Azure App Service platform that determines how many function instances to scale out to. But the host runtime itself has always been open source, and that means that you don't necessarily have to have it on Azure itself. You can run it, well, obviously, you can run it locally, and we have a great local development experience. You can do local debugging. You can do local testing. It's set up so that it integrates nicely with automated testing scenarios. You can also run it on Azure. We have a couple of different hosting plans. There is the classic consumption model, which is kind of what I've been describing as the dream of serverless. I only pay for what I consume and nothing else. Has a couple of pitfalls, and we've come up with some mitigations, as I'll cover. There is the app service model, which is your dedicated hosting plan. Sometimes people want to run functions, but they know that they're going to have a consistently high workload, or they're going to have some very consistent traffic, say something that maybe follows business hours very closely for a particular time zone. And in that case, the auto-scale rules of app service and the always-on capabilities can be a good fit. It's not pure serverless, but we're finding that kind of a hybrid model can often meet some of the demands that enterprise solutions have. It's also possible to put functions in a container and put that container wherever you want. That can go on-prem, that can go on cloud, and this is often a good solution if you have custom hardware or custom dependencies that we don't directly support. You have more control in a containerized solution. Because it is literally, you can compile the binaries, you can upload it somewhere, run it against your app root directory and go. You can take it to other cloud providers. You can also take it to other places on Azure, like AKS or Service Fabric. We intended this to be very, very portable. And if you're running Azure Stack, we work there too. Great. So as I was talking about, there is a bit of a gap in the consumption plan. And how many of you have, okay, there's a term for it. How many of you have encountered cold start? How many of you like it? Okay. So yeah, cold start is an issue, and that's because if you are scaling down to nothing, and your app doesn't get any requests, there's nothing in your queue, there's no HTTP requests coming in for a while, you do have to spend a little time to provision a new instance of your app when a new request comes in. And that can lead to a bit of startup latency. Now, in some scenarios, this is perfectly acceptable. But in others, say if you really want a fast rate of return on your HTTP API, no matter what, this isn't just going to fly. So over the past year, we have been working on a new hosting offering that is currently in public preview, and we call it the Premium Plan. So what the Premium Plan does is it allows you to have that almost limitless auto-scale of the consumption plan, but with the reliability of what we call the dedicated plan, the app service plan. And it's also allowed us, and we do this basically by, on the back end, we kind of hybridize the two. And we kind of have a blend of app service and consumption that they work together. But there are some added benefits to this as well. One thing is that in the consumption plan, sometimes you want to run inside a VNet. Sometimes you need that network isolation. Not possible on consumption, but it is possible on the premium plan. We've also extended the run duration. So under the consumption plan, the limit is set to 5 minutes as a default. You can set it up to 10 in your configuration settings. But sometimes you have some pretty, sometimes we notice that functions are not always just quick little toy functions. Sometimes they're doing some very complex or long-running stuff, and you need your function to run for a bit longer. So the run duration has been upped to 25 minutes. If you are on a full app service plan, I will note there is no run duration. Your functions could run until the heat death of the universe or until Microsoft goes out of business, which will hopefully be about the same time, she says, with hope for job security. And it's also predictable billing. So there's a maximum plan size. You will never scale above that, but you may very well be below based on your traffic. So this kind of gives the concept of premium functions and how it works. This is basically the ideal of serverless, namely that as my load increases, my consumption instances increase to match that load, and I'm covered. Reality is a little more like this. And so I get some load coming in. My scale controller says, ooh, hey, I've got some load. I need to flip up another instance, but there's that little bit of lag. And in that little bit of lag, you are going to get that cold start latency. And so what you'll see as your app scales is you'll see these little jumps like this, and eventually it'll catch up, and you'll go down to a nice latency again, but that's not very great for those requests that came in during this period of stabilization. So what Premium does is it allows you to basically provision a certain number of reserved instances. These are instances that are always available, they're always warm, and ready to catch new requests and invocations that are coming in. And as soon as an invocation comes in, like you can see, is my laser pointer working? No, battery's too low, okay. But as soon as a request comes in and that reserved instance is handling it, the premium plan controllers are going to scale out another reserved instance. So you've always got a little bit of a buffer up to your max plan size, and there's always something covering you. Now, if you were running this on app service, a dedicated app service plan, and you knew you were going to have this kind of load, you would have to basically say, all right, I'm going to need something to handle the max load, especially if this is a very bursty workload, if this is something where you can't predict when that max is going to come in. And so you would be paying for 6 instances all the time. And I'm not going to do the calculus involved in the difference between 6 instances constantly and that curve of the premium instances. But your cost savings are realized there. So there is less compute time being used, less cost. And one other thing I'll note is that compared to the consumption plan runs on fairly lightweight VMs. But the premium plan runs on some very heavy-duty hardware. These are what we call DV2 series VMs, I think. And they go up all the way to, I believe, 4 cores, and they're pretty beefy. So I have a demo of this in action. I'm going to shift over here. So let's take a look. Over here, I have 2 apps set up. One is an app that just has a simple Hello World HTTP trigger on a consumption plan. Very simple, basic offering. The other one is that same app, but it's been deployed to a premium plan. And I'm going to use loader.io to generate some load here. And let's watch what happens to this graph in terms of number of clients that are doing the requests and then the average time on the request. And this is my last run. I haven't run this in about 20 minutes, so the thing has slowed back down. It's been deprovisioned. And we're down to 0 instances again. All right, so this is a banner ad, not what I need. This is the consumption test. We're going to start hitting this. And as this runs, you can see that we are up to about 5,000 milliseconds average time, and we're starting to go down now. We're starting to scale on we're starting to scale out to more instances, and we're starting to see this average latency decrease over time. But again, This area right here, not great, right? And if you're not so concerned with latency, that may be fine. The consumption plan is a great offering in those situations. And with, I think, like a million executions free every month, it's practically free to run. If you were at Troy Hunt's keynote and you saw him and talk about his site, Have I Been Pwned? That runs on Azure Functions, and he's done a couple of blog posts. He's definitely posted on Twitter about the amount of compute he uses and his Azure Functions bill ending up to be something like $7 a month. It was pretty low. Okay, so our test is finished, and we can see there's this initial high peak, and then we come down to a relatively low latency as we get a hang of things. Still, let's take a look at Premium. So with Premium, again with the banner ad, but less this time. All right, Premium, you can see this graph is much lower to scale. So we're peaking at about 80 milliseconds of latency, so sub-second latency here. And you can see our, let's see, we've got about 1,300 clients active. You can see there's another peak here. So this is not the best. This is something that we're working through as we move this from preview to GA. But you can see that we're starting to flatline around 11 milliseconds of latency. Same app, different plan. Over here, we're around 90 milliseconds of latency, and our peak was somewhere around 4 seconds. And we had about 1,600 clients active at that time. So that's just a quick demo that's meant to kind of show you the power of the Premium plan in action. Okay, let's move back here. Show from current slide. Da, da. Okay, cool. All right, so one other thing that we have done, thank you, no, come back. Okay, cool. The other thing that I was talking about with Premium is namely that it allows you to do virtual networking. So we do get a number of requests from customers who say, I want to run functions in a VNet. I want to run functions, but I cannot run in a public cloud. And there's a couple of different offerings for this. So consumption plan, pretty much you're public. All bets are off. Premium plan, we do allow you to do VNet connectivity. We have VNet integration and private site access. The app service plan can get even more restricted, but again, you have that greater cost. But we still have no outbound IP restrictions. And then there is this last one, which I haven't talked about yet, which is an app service environment. And that is basically a fully isolated, what we call a stamp, but a fully isolated environment for you within Azure. And that can get very pricey. So in terms of price points, we kind of go up like this. And as we do, the network isolation also goes up. So it depends on what you need for your particular solution. This is kind of an example of how Premium works with the VNet integration to create sort of this, this is how Premium works with VNet integration, excuse me. So a couple of things you can see here. You need to watch out for your dependencies. It does allow you to secure outbound calls to resources in a VNet. App service environment, this is the one I was talking about, the very, very isolated, very hermetically sealed. Yeah, this is if you need a, this is for basically large enterprises, if you need something very, very private, right? You're like, I want my own cloud, but I don't want to maintain the infrastructure for my own cloud. Okay. So there's another option that I talked about, and that's namely if I want to run on-prem or elsewhere. A lot of people are looking to Kubernetes. And we have found that this is really useful if you want to, say, run your functions app in one environment or shift it to another, or you don't necessarily know where it's going to land. How many of you have worked with Kubernetes before? How many of you are familiar? Okay, a couple of folks. I am not particularly an expert in this area, but I can talk a little bit about what we have done with containers and scaling. So another thing come on, did you die? There we go. All right, so one of the things about Kubernetes containers is that when you need another instance to handle load, this is done on a reactive basis. So you're looking at the CPU and the memory usage within a container to determine when you need to scale out to another instance of that container, spin another one up. And that can lead to some lag time. It's not as proactive as a functions model. So Functions has come up with the Kubernetes-based event-driven auto-scaling, which is, as its name suggests, it monitors event queues coming in. So it looks at things like the length of your queue. It looks at your Kafka stream depth. It looks at these things before it ever hits your CPU or memory and impacts that and does the scaling on its own. This has been fully open sourced. It's available today. And it's also introduced a number of new Kubernetes triggers. So for example, we have Kafka, Azure Queues, Azure Service Bus, RabbitMQ, HTTP Queues, Azure Event Grid, and Cloud Events. We've also have more coming, like Azure Event Hub, Storage, CosmoDB, and Durable Functions, which I will talk about in a minute. Another advantage of Kata is that it does not have to proxy those events through an HTTP or through HTTP. It's a direct from the event into your container. It runs alongside virtual kubelet and AKS virtual nodes, and we do have a webinar about this coming up later in May if you're interested in more information about this. And this is just sort of a overview of how Kata works. So you have an external trigger event source that gets translated through the metrics adapter into something that the Kubernetes pod autoscaler understands, and then it'll scale out to various different function pods is the very, very simple version of how this works. Okay, so when to consider Kata? When you want to run functions on premises, when you want to run it on edge devices, if you are already a containerized Kubernetes shop, if the rest of your solution works in that way, this will mesh nicely with that. If you're not sold on Azure, if you're worried about vendor lock-in, we don't want you to be. Or if you need more control than the other functions hosting options will offer you. Remember I said that we see this one being asked for a lot from people who say, well, I have these custom dependencies that I need to access. I have this custom hardware that I need to run on. The plans on Azure themselves run within the app service sandbox, and that has certain limitations for security purposes. But if you need something that goes beyond those, this may be the solution for you. All right, so that's a lot about hosting. I'm going to talk a little bit about App Insights, and this is not the best of slides, but what I do want to say is that, so App Insights is sort of the recommended experience for using Azure Functions on Azure. And we have done significant work over the last year to make the telemetry that we send to Azure to App Insights a lot richer. And one of the things that this has resulted in is integration with AppMap. And AppMap shows you basically how your function chain works. So you can identify if you have a chain of functions, if you have a whole network of functions performing, an operation in steps, you can see where your latencies are. You can see where a request failed, and you can break it down piece by piece and pinpoint where things are happening in a nice graphical user interface. This information is also available if you're going through the Application Insights query language, which is actually exactly like what we use internally for investigating issues and live sites and so on. It's capable of very fast queries across very large data sets. But this is obviously a much easier way and much more user-friendly, presentable way of figuring out where there are problems in your application. All right. I do want to talk a little bit about security. So one of the things about functions is, where am I going to keep my credentials, right? I want to keep my credentials secure somewhere. I don't want to just be storing them, God forbid, in my application code. Or in maybe even in a config file that I may accidentally check into GitHub, and then the GitHub ransom ransomware thing that has been hitting the last week may shut down your whole repo and ask for about 0.75 Bitcoin to get it back. I see some nodding heads, so somebody's read that news story. Right, so this is not great. We want to do something different, and there's a couple of different ways to do this. We have within Azure Managed Service Identity and something new called Key Vault. And again, over the past year, we've been doing a bunch of work to integrate functions better with that so that you can actually reference directly from your function into a Key Vault reference, keep your secrets stored in Key Vault, but pull it into your function at runtime as needed. And that comes with the added benefits of Key Vault, namely that you can do credential cycling, and it is encrypted. So again, this is not totally my area. We're getting to that, but these solutions are available. All right, I know I'm going kind of fast. So DevOps. Something we haven't talked about yet. How do I test? How do I deploy? How am I going to basically get this thing into the cloud, handle versioning, and make changes? This is kind of what we talk about as the outer loop. I think this is a Microsoft-specific term. Someone correct me if I am wrong. Common industry? No? Okay, it's our jargon. But the outer loop is basically everything other than code run debug. It's everything that they didn't really talk about that much during, if you did a comp sci undergrad degree, this is that stuff. So source control, build and test, deploy. How am I going to run this in prod, and how am I going to monitor it? So I've already gone over the monitoring piece a bit, but what I want to bring up is Azure DevOps. If you're familiar with Azure VSTS, or sorry, just VSTS, Azure DevOps is the new rebranding, and Azure Pipelines is the dev deploy experience within that. We have a pretty good story already around .NET deployment, but one of the things about functions is you don't just write in .NET. You can write in Python, you can write in Java, you can write in JavaScript. And I know we're working on other workers. Oh, yes, you can also write in PowerShell now, because that's an announcement we did a couple of weeks ago, which is great for cloud automation scenarios. But how am I going to get it out there? So we've actually created a bunch of new pipeline templates that you can use to, that are specifically for Azure Functions to get your function into the cloud, to hook this up to your GitHub repo, or, Lord, does anyone use SourceForge anymore? Anyway, your GitHub repo or your other source control solutions. And we've also, within the Azure CLI, created a command to stand up a DevOps pipeline and connect that directly to your function app and get that up and running. So very quick, very fast. We take care of all the pieces for you. There are fewer places for things to go wrong. Okay. All right, workflows and state. So I will fully admit to full disclosure of bias. This is the area that I work in, and so it's the one that I'm most excited about. And I may go into a little bit of detail here. So the idea of functions is that they should be quick, they should be small, they should be fast, they should be stateless. And this works great if I'm, say, resizing a blob image, but what if I need to do something a little bit more complex? What if I need to, say, take the result of one function and put it into another function, and then put that result into another function? It is possible with what I refer to as vanilla functions. I can put a queue in between two functions, write the output to the queue, use that queue as a trigger, and keep going. The only problem is that now I end up with a bajillion queues, or well, n-1, but still, it can get quite large. And I don't really have any place that declares that structure that says this feeds into this, feeds into this. You get to a point of, well, in my experience, you get to a point of tribal knowledge where either you have a giant Visio diagram that shows how your system fits together, is rapidly outdated, and really only one person really knows how it works, and you really don't want them to leave. Or you just don't know, and you have to spend a lot of time tracing through to find out. AppMap can help you with that, but it's still kind of a pain. Plus, you're paying for all those additional resources. Here's another one. Parallelism. So let's say I get a batch in, like I can from, say, an event hub trigger in functions, and I want to go and I want to process all of those events individually. Well, I can do that. I can write to a bunch of queue outputs, but how am I going to aggregate that data back together, right? I have to monitor for when all of those functions are complete. I have to pull that all back together, and I have to do that somehow. And you can do it, but it is painful. It is messy, and it is not really a good time. What about if I want to aggregate several events? Let's say I want to have something that will listen for events and update state and take action based on the kind of data that that's coming in. That can also be very difficult because, again, each function invocation is stateless. It has no concept of any other invocations that are happening around it. What if I want to do some long-running process monitoring? Well, you might say, well, Katie, just use a timer function. It's like a cron job, and go that way. What if I want these processes, though, to be configurable? What if I want them to work for particular things? What if I want to say, hey, I want to monitor, I don't know, the weather in Bellevue to tell me if it's raining because I don't want to go outside when it's raining, in which case I really shouldn't have moved to Seattle. Or what if I want to spin up a bunch of identical monitoring processes in, say, a connected device scenario, but for different device IDs? Well, with your trigger function, you could go and you could create as many timer-triggered functions as you have devices, and that rapidly gets very large, and you are copying over code multiple times, and it's just kind of redundant and icky. What if I want to, say, like, change the latency of my monitoring cycle? You know, if everything's great, cool. Check back in an hour. If everything's not so great, all right, I want to watch this very closely for the next 10 minutes to make sure that my state is resolved. These are all hypothetical examples, but they could happen. What about if I have a long-running process? So we talked about how we've upped the maximum execution time of functions to 25 minutes from 10 minutes, default 5 minutes in a standard consumption plan. Well, in some cases, I have a lot of work I have to do on the back end, but I want my client, whoever called this function, to have a response right away so that it doesn't just have an open connection hanging and it has no idea whether things succeeded or not. There's a pattern for this. It's an HTTP 2.02 response pattern where I return a response that points to an endpoint they can monitor for the final result. I can set that up in regular functions, but again, it's kind of boilerplate code that is standardized, and it doesn't really add business value. And then finally, what if I need to involve humans in my workflow? What if I need to bring in events? What if I have, say, if I want to do like a two-factor auth situation, or if I want to start off a workflow that brings in, that requires a manager approval or a couple of managers' approval, right? This, again, is something that I could set up in regular functions, but is difficult. And you're like, okay, Katie, you've made your point. This is all hard. Well, it's not hard. It's just a pain. How are you going to solve it, right? Okay, next slide. So durable functions is an advanced extension of Azure Functions. It's actually the area that I work on specifically. And what this does is it introduces state. It allows you to run stateful, long-running workflows within functions, taking advantage of the serverless consumption thing. And the way it does this is that we've kind of created a couple of different classes of functions. So there is your client, which is stateless, which you can use to start off any of these orchestrated workflows. That can hook up to any trigger that function supports. So, excuse me, I can start on an HTTP trigger. I can start on a queue trigger. I can start on event grid. Anything that works with all of them. But what that can do is it can start up the orchestrator function, and this is the stateful piece. In the same way that a orchestrator, like in a conductor in an orchestra, conducts various musicians to play various parts, an orchestrator function conducts various activities and instructs them to do various things. The orchestrator allows you to define a workflow in code, define async work, and then go to sleep while that async work is being done. So you're not billed for the time that your async work is running. You are billed for the function doing the async work, but your orchestrator itself has shut down and is waiting. No point in keeping it up. The activities are what actually run a lot of the work. The orchestrator is intended to be pretty lightweight, just kind of a scaffolding of logic that allows you to lay out, here is that path, not in Visio. And we've also, at Build, announced an early alpha preview of an actor-like model for entities. So how many of you are familiar with like actor-based programming models? Okay, a couple of folks. Yeah, basic idea is you have an actor. It can receive messages that alter its state and communicate with other actors in the same way. Very, very basic overview. But this is something that we've had requests for from the beginning in durable functions. We found that the underlying framework we were using at first did not really support this well. But over the past year, we've worked with Microsoft Research to pretty dramatically restructure that underlying framework and allow this to take place. All right, so what does durable functions look like? This is an example of a durable functions orchestrator, specifically the first chaining example that I showed you in that 6 grid a couple slides ago. So one of the things about this that I want to point out is that we're using a lot of very familiar non-distributed C# coding conventions, like we're using try-catch blocks. So in this case, if I have an exception that happens in one of my functions that I'm calling F1, F2, or F3, and I don't handle it within that function, that's going to get marshaled back into this orchestrator where I can handle it, just like if I had called out to, say, a different class library in a non-distributed solution. Another one that I want to point out is that we are using the async await notation for calling this async work. And at each await call, we're going to kind of checkpoint, go to sleep, and then wake back up again. And let me check here, 12:21 p.m. OK, so we're doing good on time. All right, so pointing out here, this is the orchestrator function binding. Right here, these are the activity functions that I'm calling. And this is kind of going into the patterns in a little bit more depth. Here's function chaining, you can see. Here's the asynchronous HTTP API. That's the quick response and then the delayed endpoint that I'm going to monitor for end work. So what's happening here is I'm taking in data from an HTTP trigger binding. I'm using that event data to start a new orchestrator. And then down here, this last line, return starter.createCheckStatus response, is returning a JSON payload that contains various management endpoints. So that's for monitoring status. That's for monitoring. That's for terminating it if you need to. For sending an event to it. What's the other one? For rewinding it in case if a part of it has failed and you need to go back to your last good state. That's a preview feature. Still working on it. There we go. Come on. There we go. This is the monitor pattern I was talking about. So this allows you to do a sort of a richer status monitoring experience, allows you to take action based on what you get back from that monitoring. And you can notice that this is pretty concise code, and it looks a lot like what you would see in a non-distributed solution, which is one of the parts that we really like about it. Let's see here. Human interaction got tiny. I don't know how that happened, but I do realize that I have missed. Have I missed parallelism? Oh, all right, that's not great. All right, so, but human interaction is another one. This is a, so the way that we do this is by using event sourcing. We write a list of the events as they happen, and we replay them to rebuild state. This is a brief animation that kind of shows you what happens. An orchestrator function will wake up. It will run through its code. When it hits a request for some async work, it will check the history table to see if that work has already been completed. It really has no knowledge where it stands in the execution cycle because this is done via replays. But if it's not done, it'll schedule the activity function. Activity function will wake up. Orchestrator function shuts down in the meantime. Activity function does the work. that will trigger the orchestrator function to wake up again. And one point I want to make is that the orchestrator will start executing from the very beginning all over again. And again, it's like it's waking up anew. It has no idea. So it will go and it will look against the history table again, see if it has executed. If it has, great. It'll continue past that point. And this is a very, very, very simple execution. So we would normally have more steps, but at that point, it's going to create output and end. So that's all great, but one of the things that we've announced at Build is the new pattern, namely of event aggregation. So here we have entities that, again, they have a particular state. This is stored kind of more at the application level, more than in the entity itself. And you can write operations against them to do various things. This is an example of a simple counter where I'm sending add, subtract, and reset operations to change the state of it as it goes, and on each time it's going to restart with a new state, which I can then query from some outside source to use elsewhere. So this opens up a number of new patterns. This is a couple of things going over entity functions and basically the way they work. They're a little different from an actor scenario in that they will be automatically created. They're focused more on durability than latency, namely if your VM gets recycled, if your instance shuts down or is deprovisioned, if you're running on the consumption plan, you can, like with other durable functions, start back up and have that state available. You're not going to lose anything by your machine kind of just going. All right. They can be non-deterministic, which is a limitation of orchestrators. This is a whole talk in and of itself, so I'm kind of going a bit quickly through this, but if you have more questions, ask me later. And then, all right, so that opens up a lot of interesting scenarios that we've seen folks using. One example of using durable functions is Fuji Film in Japan. They have a large, it's almost a Flickr-like photo indexing service, and they also cover the Japan is really, really big on baseball, really big. I used to watch my dad, and he would watch them, and I could not tell if he was angry or happy or not. He'd just be going, go, yes, go, Ike. I'm like, Mom, is he okay? Yeah. Anyway, so they're there, and they're taking thousands and thousands of photos of these players during games, and then you want to get these out and useful in media very quickly. So they have built a data ingestion pipeline, basically, that takes these photos and using machine learning tags them of who's in this one, right? This player, that player, based on uniform numbers and however else the algorithm does it. And they're doing this with durable functions to process thousands and thousands of photos with, I think, like a 2-minute latency. It's pretty darn low. We have a case study about it what is it? We have a case study about it in our case studies section, which I can get you the URL of later. Anyway, so that's kind of a very brief whirlwind tour through a number of the things that we do to support various enterprise scenarios and concerns in serverless, kind of building out the serverless model, making it sturdier, more robust. If you want to learn more, we also have a serverless community library because often I've gotten feedback before that the examples in the docs are very simple. They're like hello worlds. And then there's these case studies of full-blown, full-on enterprise solutions, but where is the middle to kind of help you go from A to B? And the serverless community library is a great place for this. This is community-driven. It has a number of samples and examples built using Azure's serverless components to do kind of mid-level type solutions. So something more complex than what we can fit in the docs, but something that's not so large that it just overwhelms you when you take a look at it if you're unfamiliar with serverless. You can check that out there. This is kind of just a quick rundown of all of the stuff that we talked about at Build. The aka.ms link at the bottom has our blog post. So these are the big highlights of the last 6 months. If you're interested, you can check those out there. And then I highly recommend, if you've been interested in any of the topics that I talked about today, you check out some of these sessions from Build that are available online. These are where my colleagues kind of go into these topics in much greater detail, and because they own the feature areas, much greater expertise. I will also note that because we're open source, you can find us on GitHub. It's Azure/Azure-Functions is our main repo, and that leads to about the 18 other repos that we have split our stuff out across. We're available on Stack Overflow, we're active on Twitter, and we monitor our user voice account. So if you have any questions about onboarding to serverless or how you could use functions, or even like, so I kind of built this in functions, but did I really build it right? We would love to sit down and talk with you. That's actually one of my one of the things that I really like is acting as a conduit for you guys to the product group, because it can be immensely helpful. It helped me a ton when I was a customer of functions to be able to talk to the product group and just get that feedback from the people who built the stuff. So I'm getting the 5-minute signal from the back, so it looks like I'm at about time. Thank you so much for coming. Oh, 10-minute signal. Okay, well, I guess we have a little time for questions in that case. So if anybody has any follow-up questions, I'd be happy to take a couple at the moment. Hand right there. I don't believe it's yet available in the government cloud. There's usually a lag between when it rolls out in Azure's public cloud to the government cloud, but it's also in preview right now. So I would watch in the upcoming months for that. I'm afraid I don't have one off the top of my head. Yeah. Yes? There are actually. So C# script is one of the languages that we offer. It was actually the first one that you could write functions in. And the thing about C# script is that we compile it down to IL at runtime. So you're hitting that performance bottleneck right there. We highly recommend over the, if you're developing functions in the portal, that's great for getting little toy apps up and running and kind of testing the waters, but we highly recommend using the Visual Studio or the Visual Studio Code experiences instead. Visual Studio has this rich set of, like I said, it has autocomplete, it has, what is it, IntelliSense, that's the word. It has IntelliSense, it has the attribute-based bindings, and I know we've had some talk. I don't think there's been any resources allocated to it yet, but one of the things we want to look at is, Roslyn-based detectors to tell you, hey, maybe this isn't such a good idea. Hey, you forgot this. Hey, this might not work, based on our experience and common pitfalls and gotchas. Cool. Okay. Right, well, if you have any questions, I will make my slides available. I encourage you to reach out to me, and thank you very much for coming.